Alright, in this video, let's continue the work on our hit effect system. We're going to address the management aspect of all of our hit effects.
Now, what exactly is the management system going to do?
Well, it's going to control the total number of hit effects that are in existence. It's actually going to manage instantiating all of our hit effects right off the bat and dropping them into a list. So that way, rather than instantiating the effects on spawn, we instantiate them once, and then simply reach back into this effects list every time we need to grab an effect and spawn it.
Okay.
So we're going to give ourselves the necessary facilities to store all the effects in existence and to manage them so that we always walk through and pull out the oldest effect to show. The idea is that whenever you show an effect on screen, you may need to spawn another one before the first one is done animating. So we want to make sure that we always grab the oldest one. The way we'll do that is we'll simply make sure we walk completely through the list of all of the effects, then wrap back around to the beginning.
Gotcha. So what we're going to create all of our effects at the beginning, and then give them all a number and make them all stand in line, and then they're just going to go out one at a time. And when they're done, they'll get back at the back of the line.
Exactly. And that way, element 0 is going to be the first one who gets spawned. That way, if we do run into a scenario where we underrun on our effect cache, we'll run into a scenario where we grab the oldest one. Let's say we start at 0, we get all the way down to, say, 16, and then we need to wrap back around to 0. For some reason, we've spawned so many effects, and 0 isn't done animating. He is the oldest one, so he'll be the one closest to being done animating.
So he'll just cut off, and he'll stop in the middle of his performance and jump to the new location.
Yeah, he'll stop in the middle, disappear, and jump to somewhere else.
Gotcha.
But again, we're going to set up a scenario where we have up to 16 effects that can be shown simultaneously. So that means you'd have to have a very fast node hit rate to be able to exhaust all of these instances.
Well, yeah, if they're all going for, what, 0.2 of a second, you'd have to get more than 16 of them done. And that's some fast drum playing.
So yeah, the idea is that 16 really isn't that many. If you look at the grand scheme of a particle system, 16 effects isn't that bad.
No.
But it is still more than enough for the normal gameplay of the game.
Right.
So let's get started with these management fields. We'll jump all the way back up to the very top of our hit effect class. And let's drop down a comment saying that we're going to place some effect management. So we have our effect management fields. The first of which is going to be a list of hit effects. So we'll make a static list of type hit effect, and we will call this list effects. And we'll set this to be equal to a new list of hit effect. So this is the place where we'll store all of our effects, the ones that are ready to be used and the ones that are currently being used. Next up, we'll make an index variable so that we can always point to a specific element inside of that array. We'll make a static int called effect index, and we'll use this, actually let me correct the spelling at the beginning, effect index, where we will use this index to advance element by element inside of the list. So every time we spawn an effect, we'll advance effect index.
Okay.
Then when we hit the end of the list, we'll wrap effect index back around to the beginning of the list.
That just keeps track of whose number is up in the waiting room of effects.
Exactly. And we'll have one more field, a static int called effect count. And we'll set this to 16. We'll use this as a parameter to say how many effects we can have. If we look at the effects list as our effects cache, we'll say that this is the size of our effects.
Gotcha.
Effects cache. Alright, moving on from here, let's put together some methods that we can use to manage all of our effects. We'll begin with a method called initialize. So jumping down here, we'll jump in right before our instance methods. Let's actually drop down a comment, we'll call that effect management methods.
And I imagine initialize's purpose is just to make all 16 of our effects.
Exactly. So we'll make a public static method called initialize. And inside of initialize, actually let's give this a return type as well. Public static void initialize. So we need to loop through all of our effects and get them created. So we could say, we'll make a simple for loop we'll run through I all the way up to effect count, and as we're looping through, we want to make sure that we spawn new instances of hit effect and store those in the effects list. So we have effects dot add, and then we'll add a new instance of hit effect. And we could mark, and we could even say that we are going to here pre-allocate our effect instances. Now, one other thing we do need to do inside of initialize is we need to set up our texture origin, because again, we got the texture ready to go over in style, but we do need its origin for later in the instance draw method of hit effect. So let's set up our texture origin. We could say that texture origin is equal to a new vector2, and that vector2 will be style, basically half our texture's width in x and half our texture's height in y. So we'll reach into style.effectTexture.width divided by 2 and style.effectTexture.height divided by 2 for y. And then just to make sure all this fits on screen, I'll jump down and tab the y component over.
Okay.
So it takes care of setting up our texture origin. And with that, that's all we need to do inside of initialize. Again, just setting up all of our effect instances. Alright, moving on from here, let's put together the method that will be used to spawn an individual effect. If you'll remember from the instance section, the spawn method is in fact private. We can't actually call spawn on an instance outside of the hit effect class. And we're going to provide a static method to facilitate the spawning of effects. So we'll make a public static void method called spawn effect. And spawn effect is going to need to take in two things: the position the effect should be spawned at and the color that the effect should use. So we'll give a vector2 called position and a color parameter called color. Now inside of spawn effect, we need to reach into the waiting room of effects and grab the effect whose number is up and tell that effect to spawn. So we'll reach into the effects list, sub effect index, and we'll tell that effect to spawn. And of course, in spawning, the effect itself is going to need a position and color, and we'll simply pass the parameters position and color along to the spawn call. Alright, so that'll kick off that effect and get him ready to do whatever he needs to do. Now, here in spawn effect, we need to make sure that we move our hit effect index forward to the next element that's waiting. So we'll take hit effect and increment it by 1. Now we do need to turn around and make sure that if we have walked off the end of the list, that we wrap hit effect back around to the beginning. And we'll simply use modulus to do this. So we'll take our effect index and say that it will be modulus equal effects.count. So if we actually reach the end and reach count, we wrap back around to the beginning. Alright. One more management method we need is draw effects, because again, the draw method is going to need to be called, and to make this more convenient to update inside of the game, we'll add one overall method by which we draw, and we can also take active into account inside of that method.
Okay.
So we'll make a public static method, void return, and we'll call this draw effects. We'll take in two parameters, a sprite batch and a game time. So we'll take in our sprite batch parameter as sprite batch, and our game time parameter as game time. Now inside of draw effects, we need to loop through all of the effects currently in the effects list, and if each effect is active, we will draw it. If it's not active, we'll simply skip it. So we'll make a for loop. We'll loop through all of our effects, so effects.count, and then effect by effect will check each effect's active flag. So if effects sub I dot active,
then draw it.
then go ahead and draw it. So then we can turn around and say effects sub I dot draw and pass in the sprite batch parameter and the game time parameter. So that way if the effect is not active, then the draw simply gets skipped. Alright, with that, let's build the class, make sure that everything is looking good. We have no syntax errors. So now we can turn our attention to the game class and get the effect system hooked up and ready to go. So we'll jump in here to game 1, and we'll begin at load content. Here in load content, we need to make sure that we make the call to hit effect.initialize. We'll drop down a comment to say that this section is for hit effects. And we need to look at the static method hit effect.initialize. So again, make sure we get all of our instances set up and get our texture origin ready to go. Alright, from here, now we need to make sure that all of our effects get drawn. So we'll scroll down to the bottom to our draw method, and we'll jump in here right after screen.activeScreen.draw, and we'll drop in a call to hit effect.draw effects. We need to pass in a sprite batch and a game time, so we'll pass these parameters along. Now, one other thing we want to do with our hit effects is we would like to draw each individual particle with additive blending.
Okay.
And right now, all of our drawing is using alpha blend, because that's the default in our sprite batch begin call. Everything so far is using alpha blending sprite by sprite. Now, in order to specify a different blend mode, we have to begin a separate sprite batch call in order to be able to specify that. That means we'll have to end off our sprite batch call for all of our screen drawing. So that means we'll need to do something like taking our screen drawing calls. So we'll call ActiveScreen.draw, and then we'll call SpriteBatch.end. So we'll end off that batch entirely. Now we're free to begin a new batch. So we'll call SpriteBatch.begin. This time we'll specify a sprite blend mode. And in this case, since these are our particles, we'll give SpriteBlendMode.additive. Now when we draw the log, we want to go back to drawing with alpha blending, so we'll end off this batch. So another call to SpriteBatch.end. And then when we go to draw our log, we'll do the same thing. We'll begin a new sprite batch, SpriteBatch.begin. This time we'll use the default overload, so we'll end up with alpha blending. And then we'll move this last call to SpriteBatch.end into the if statement.
Okay.
Because we don't want to leave a stray call to SpriteBatch.end, otherwise that'll cause problems. So now we actually have 3 different cases of sprite batch begin and end being called, with the middle one being additive. The other 2 will be alpha blend.
Gotcha. So one's for the game, the middle one is then for the effects, and the last one's for the log.
Now with all of these in place, we now have the effect system hooked up and ready to go. So let's turn our attention to the screen game, and let's spawn effects whenever a note is hit. So moving up here to our game folder, let's bring up screen game. And here inside of screen game, let's go down to song note hit. So of course we're playing the appropriate note whenever a note gets hit. Now let's turn around and spawn a hit effect at the location of this note. That means the first thing we'll need to do is we'll need to get the location of that note. Fortunately, the renderer system is set up with a method that can resolve note positions to actual screen positions. So we'll do this by making a vector2 variable, which we will call note position. So note position can be equal to renderer, because now we need to get access to whatever renderer is currently being used. So we'll grab renderer.activeRenderer, and then we will call upon the getStaffPosition method. We need to feed in a tick value. In this case, we want to spawn the effect at the center of the screen, so we'll specify a tick value of 0. And we need the core thing that we're looking for is to be able to resolve the track position. So we'll drop in note.track. That will give us the appropriate position in Y. we'll also feed in the current song, and then we can end off the call, because of course song is coming from the event handler itself. So that means if we're dealing with player 2's version of the song, it'll be lower, but we know that our renderer is capable of handling the second player's song, so we'll actually get positions that will line up with the bottom staff instead of the top staff.
Right.
Alright, now that we have the position established, let's turn around and spawn the effect. We'll look at hit effect, and we will call spawn effect, where we need to pass in a position, which we'll give as note position. And we need a color, so we need to resolve the color of this track. And we'll do that by looking into the track colors list inside of config. So we'll grab config.trackColors, and then we need to specify which track color, and we'll pass in note.track. That will take care of our spawn effect call, and at this point we should be ready to jump in and test. So if we run the game, we'll jump into single player to begin with, and we'll grab the standard rock song, and now watching notes go by, nothing immediately happens, but if we hit notes,
nice,
we see a particle effect spawns. So all of that seems to be working well. There is one last thing that I do want to add. You'll notice how all the effects stay with a specific size and actually look fairly slow as we're hitting things effect by effect.
Yeah.
Let's add a little bit of a scale value to each individual particle. So going back up to our draw method, if we jump over to hit effect, let's jump down to our draw call. So let's go back to the instance methods inside of hit effect, and there at the very bottom we have our instance draw. Now earlier we had just dropped in a value of 1 for our scale, but let's actually have our particles scale out. Let's have them actually scale down as their life progresses. So in order to do that, let's drop in inverted age, because again, that way when the effect first spawns, it'll be its full size, then as time progresses it'll get lower and lower as it goes closer to 0.
Shrink.
And so each of the particles will shrink. So let's see what this looks like.
Oh, nice.
So much nicer. It almost gives more of a snappier feel to the effect.
Now, granted, at the recording rate that we're capturing this video, you may not be able to see that all that well. So hopefully at this point you've been following along with the video and you see it on your end.
Exactly. It'll certainly look a lot cooler when you see it at the full frame rate.
Yeah, absolutely.
Now, one last thing to test is let's jump into multiplayer mode and make sure that players 2 hit effects do spawn at the bottom track.
I have my controller ready.
Alright, here we go with rock.song. So we do indeed have effects getting spawned at the appropriate place at the appropriate time.
Nice.
So all of that is working very well.
I was totally hitting the wrong button for the kick.
Yep, and it was funny too because we were hearing the click sound every time, though the click sound was on beat.
Yeah, I was nailing the trigger instead of the shoulder button.
Very nice.
Oh well.
But with that, we now have our hit effect system fully in place and tested. So we've got all of the instance stuff working perfectly for the individual spawning, and our management code seems to be working well for causing those effects to appear at the appropriate time.
Awesome.
So with that, that's going to wrap up this video.